Good evening, everybody. I'm Bruno Tassin, and I'm going to talk about plastics with you for maybe 1 hour. First of all, I would like to apologize because of my poor English, and I hope that you will be able to understand what I would like to say and to explain to you. I think that we have two possibilities. I can speak during 1 hour and then we move to questions, or you can also ask questions during my presentation. I think that it's the best solution. So if you have any questions, please raise your hand and we will move to the questions and to your questions. So this is coming from a demonstration on the climate protest in March 2019. And it means in French, without plastic, it's more chic. So it was a little girl with this advertisement. I try all the buttons, but it doesn't work. Okay. So I would like to present you a few points concerning plastic contamination from both an environmental point of view, but also moving to some much more general questions related to economy, and especially the question of recycling of plastics. And also at the end, I would like to discuss with you the questions of the International Plastic Treaty, which is under discussion at the moment. And the next round of discussion will take place at the end of this month in Busan in Korea. It is perhaps the last round of discussion. We will discuss that later. Well, I have a background, a few words about me. I have a background in civil engineering. At the beginning of my work, I worked on mathematical modeling, and I work on the questions of lake restoration, so re-oligotrophication of lakes. And I worked on the Lake of Geneva, the border between France and Switzerland. And then I worked many years on the Lac du Bourget Lake in France, in the Alps. And then I moved to also mathematical modeling, but modeling of water quality in runoff water, so the waters that are that occurs during rain events in dense urban areas, and these waters are really polluted because there are many contaminants in the city. And the idea was to try to assess the behavior and of this water in the urban water system and especially the sewer system. And then I move from the mathematical modeling to the observation of pollution, and I work with students working on the contamination of urban hydrosphere with a specific focus on two contaminants, two endocrine disruptors that were bisphenol A. Maybe you know this substance, you heard about it, and alkyl phenols. I don't want to speak about that, and perhaps you don't know alkyl phenols, but it's a very common contaminant, and it's present especially in products that are used to clean the soils at home. And since more than 10 years now, I'm working on microplastics and macroplastics in freshwater and in urban and peri-urban catchments, so where the water flows. And I will tell you a few results about that, but I will put my talk in a much broader way. I have always this problem. So, what are we discussing about? First of all, I would like to say you a few words concerning the production and also the consumption of plastics, and also the questions of the plastic waste after that. Then I will tell a few words about plastics, because it's not a very simple product. It's a very complicated product with many substances inside, and I think that it's quite important to have a global overview of that point, because it has very important consequences on the health issue that is linked to plastic. think it's an internet problem. So là, oui, ça c'est maintenant c'est bon, mais non, c'est le PDP, il doit être par là. Okay, great. And then we will discuss the questions of plastics in the environment. What are the forms the plastics are available in the environment? Where are they, and what is their impact? Then the questions of the recycling of plastics, and as I said previously, the questions of the International Negotiating Committee on Plastic Pollution, that's the official name of this plastic treaty, which is organized by the United Nations Environmental Programme. So, production and consumption. Maybe you saw previously this figure. So it shows the increase of plastic productions from the beginning of the 50s to 2022. That are the last values that are available. And if I consider both the plastic materials and the plastic fibers, the production at the moment is around 500 million tons. So it's really a lot. And what is really impressive is the growth of these values. So we have an exponential growth. And here you have the COVID event. So despite the fact that the GDP of the, I think in France it was less, minus 7%. At the world scale, I don't know, but the production of plastics didn't decrease. Here you have the preceding economic crisis on 2008 with just a very small decrease in plastic production. And you can also see here the first oil crisis in 1973 with just a very small movement. So this is really impressive because the growth is really important. So the plastic production was multiplied by 50 between my birth in 1961 and now, or a few years ago. So it's really much more than other trends. For instance, during the same period, the energy production was just multiplied by 4, if my memory is correct. And I would like to put a few more points on that figure. Here in 1958, a first movie, an advertisement movie, was produced in France, which is called Le Chant du Styrène, and we'll show you that later. And it's a very famous movie because it was produced by Raymond. It was produced by. I will see it. I have the figure after, and so it was to show how plastic was really important in our society. In 1967, you have the famous film The Graduate, and there is a very short sequence about plastics, and I will try to show you this sequence. Maybe I can try to do it now. If so, I have to do Control Alt, Control Tab. Zut. I have to put the, sorry. My mic is off.
Excuse me, Joanne. I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, sir. Yes.
Plastics. That's a deal.
So it's quite funny. So it's quite funny. What happened?
You need to switch the sound off again, otherwise
Ah,
we'll
okay.
get echo.
And so a little bit later, the first plastic bags ban in Bangladesh in 1988. It was in Bangladesh because it's a country where you have very huge rain events, and the presence of plastic bags on the street was helping to create big floods because the water was couldn't get inside of the sewer system because all the gully pits were closed because of plastic bags, and because of that they decided to forbid the use of plastic bags. A little bit later in Ireland, a first tax on plastic bags at the beginning of the 21st century. And here it's just the first scientific work on plastics outside of the ocean. That's also interesting to see that the first scientific work were dedicated to plastics in the ocean, in marine environments. At the beginning, in 2015, plastic bag ban in the European Union. And next year, so at the 1st of January in 2025, it will be compulsory in France to have plastic filters in washing machines. It's a new rule. And we hope also to have next year an international plastic treaty, but I put a question mark because we are absolutely sure of that. So this is the first, this is just a slide about the Chant du Styrène. So the text was written by Raymond Queneau, which is a famous French writer. And the conductor was Alain Resnais, who is also a very famous film maker in France. And the beginning of the text of this film, this movie, is based on a famous poem from Alphonse de Lamartine, which was who is from the 19th century. And this was the... And so at the beginning of the 60s, in 1964, the questions of the risk linked to plastics increased, and so causing concern. So all at that time, only oil and wine was sold in plastics. And so there was a question, so are they harmful in the long term or not? And you can find a film about that on the French archive from the television. So the scientists worked also on plastics. So the first scientific papers in 1972. The discovery of the Great Pacific Garbage Patch in 1988, and I don't know, but the French translation of this Great Pacific Garbage Patch is the septième continent, the seventh continent, and it's a very, very good. No, it's not a good translation, but it's very good for the opinion because it describes the presence of plastics in the ocean like a continent. And it had a very great impact on the French population. In 2004, the discovery of microplastics, and I will describe also to you the difference between macro and microplastics. And so, as mentioned in the previous slide, at the beginning of the 2010, the first works on plastics outside of the ocean. So this is from the first paper in 1972. So people were sampling water in the Sargasso Sea, and they encountered, I don't know if you can read, it's perhaps too small, they encountered plastic particles in their nets that they used to sample biological organisms in the water. And a few, so in it was not 1998, but it was 1997. So Charles Moore, it was a boat captain, and so he discovered the big presence of plastics in the Central Pacific Gyre. You know, the water in the ocean is creating big, I think gyre is the correct one, and the plastics move inside in the center of this big movement of water. If I go back in the past, the questions now is how we move to these situations that is now very present with this big quantity of plastics. And we have to go back to the beginning of the 40s. And in the Fortune magazine, there was an article on plastic, and plastic was described as a continent and a promising El Dorado. You know, El Dorado was a very famous place with a lot of gold and richness. And at that time, plastics was the promise for a gold area. And a few years later, in 1955, there was in Life magazine, the first page of this magazine was dedicated to the throwaway living, so a new way of life. And so with disposable items, and you can see that many of these items are made of plastics. Not only plastics, there are also some items made of metal for dog food, and also to cook at home, but most of these items for describing this throwaway living were plastic items. Okay. And simultaneously to the previous figure, there was an economist called Victor Libaud, who wrote an article in this journal, the Journal of Retailing, which is called The Real Meaning of Consumer Demand. And what is written in this article? Just a few sentences. Our enormously productive economy demands that we make consumption our way of life, that we convert the buying and the use of goods into rituals, that we seek our spiritual satisfaction, our ego satisfaction in consumption. We need things consumed, burned up, worn out, replaced, and discarded at an ever-increasing pace. We need to have people eat, drink, dress, ride, live with ever more complicated and therefore constantly more expensive consumption. So I think that this is a theory, this is a point of view that is really at the basis of this great plastic increase that appears in the preceding figures. So it's the same thing. But if we look at what happened after the Second World War, we see that there are many other exponential trends. And so the plastic is one of these exponential trends. And we have these exponential trends for carbon dioxide. Probably you saw that figure previously, but also other greenhouse gases like nitrous oxide and methane. There was also the reduction in the stratospheric ozone, which is now suppressed. An increase in surface temperature, and also an increase in ocean acidification. And this is directly linked to socioeconomic indicators like the increase in population, increase in the global GDP at the world scale, increase in the urban population, increase in the primary energy use, and also in the fertilizer consumption. So all the trends are going in the same direction, and plastics is one of these trends. Recently, in 2022, the Stockholm Resilience Center, probably you heard about this center. This center produced since more than 10 years the planetary boundaries indicators. And they proposed a new planetary boundary dedicated to novel entities. So novel entities, I can describe that, are all the substances that are outside of the biogeochemical cycles at the planet scale. And plastics are one of these novel entities. There are many other molecules, but plastic, which is not a molecule, but it's also it's also an artificial product. And what can describe these novel entities is their quantity, a big quantity, their presence all over the world, the origin of this presence, which is not traceable. It's not possible to know exactly where it comes from. And also, there are many information related to that substances that are completely unknown. It's some kind of mystery that are behind these novel entities. So this describe the risk that is linked, the global risk that is linked to the presence of these plastics. So plastics, it's so more or less 500 million tons per year, but it's the emission of more than 2 gigatons of carbon dioxide equivalent in 2019, and it's almost more than 5% of the total greenhouse gas emissions at the global scale. It's 10% of the global oil demand and 8.5% of the global natural gas demand also in 2019. And it is supposed that the trends that we saw in this exponential increase will continue in the future, and that plastics will account for 20% of oil and gas consumption by 2050. So in many slides you have references that you can also access directly. Please.
Just to that figure, is that also taking into account that oil and gas consumption would decrease for energy, or is that just saying basically would increase plastics?
Just with increased plastics. But so when you consider plastics, so plastics is based on fossil fuel, so you have two components. You have the fossil fuel that is inside of the plastics, that is the inside of this part, and you also have the fossil fuels that are used to produce the plastics. And this is this second part is at the basis of this CO2 production mostly. And so it is supposed that the plastic production will increase in the future, and that it will account for 20% in 2050. Yes, so yeah, you can find in the literature other numbers. For instance, the Ellen MacArthur Foundation has has values less important for both the carbon emission and also for the fossil fuel consumption, because it's very difficult and to compute this, to establish these values. But well, the order of magnitude are more or less the same. It's not 10 times larger or 10 times less. So why is it a so wonderful success? Because it's a wonderful material, and probably all of you in this room has plastics, either in the textile that you wear or on your table. I see, for instance, plastic bottles, or in your bag or in your computer. So plastic is everywhere. And it's everywhere because it has very wonderful mechanical properties, like its plasticity. So the word plastics come from plasticity. Its flexibility, so you can do more or less everything with this product. And it's quite easy to produce. It has also very specific properties. For instance, it's possible to have very specific plastics which enable the exchanges of gas through a plastic film in one direction, not in the other, for specific gases and not for others. It's also possible to optimize the light which is going through a plastic film, and this is very useful, for instance, in agriculture. So you have greenhouse that are used in, you have big greenhouse, and you also have greenhouse tunnel that are used in agriculture. And they are designed to maximize the entry of light in the window that is used by the plants to grow. So it's a very wonderful thing. And so the big problem is that plastics is not biodegradable. So as I explained earlier, it's outside of the biogeochemical cycles. So there are no bacteria that exist and that can degrade plastics. There are many papers, you can find that in newspapers also, many facts that describe that, we found a mushroom, or we found bacteria that can degrade plastics. But it's always in very specific conditions, in very small quantities, and it's absolutely not at the scale of the plastic production, the global plastic production. So it is used now in all areas in daily life, in all industrial sectors, and I will show you that later. And probably you notice that on most of the plastic objects, there is this kind of figure with 3 arrows and a number inside of this figure. And the number describes what kind of plastics is made. It's at the basis of the products that you use. You know probably the PET. The PET is very famous now because it's the only, it's one of the 2 plastics that is widely recycled. It's a polyethylene terephthalate, and it is used mostly in plastic bottles and also in textile. If you have, for instance, polyester textile, polyester is another name for PET. Another recyclable plastic is the high-density polyethylene, which that you can find quite easily. It is used for instance, to build pipes, water pipes that are present now in urban environments are made of polyethylene. You have the well-known polyvinyl chloride, which is less and less used. It was widely used in the 70s, and it's now less and less used. And the reason why it is less and less used is the presence of chlor in the polymer, and it's very dangerous in the environment. You also have another polyethylene, which is the low-density polyethylene, which is very widely used in packaging. The most produced polymer now is the polypropylene, and then you know also the polystyrene, and there is a seventh category which gathers all the other plastics, and it's called the O, like others. So 1 minute break. Okay. So for instance, you know perhaps the polyurethane, the polyuramide, and so on, and they are all included in this category. So this is the production of plastics in 2020. So the most abundant is the polypropylene. So then the polyethylene, low density or very low density, the high density, and the PET, which is used for bottle, and which is on which all the questions of recycling is based on at the moment, is only 8% of the global plastic production. And the plastics are yes. I would like to say a few words on bioplastics. Did you heard the word bioplastics? So, yes. So, please don't use that word, because it is really not clear. Because it covers two things: bio-based plastics and biodegradable plastics. Bio-based plastics are plastics that are made not on fossil fuels, but on agricultural production. But you can produce usual plastics like PET or polyethylene with bio-based material. But the plastic at the end is the same. And the problem of plastic waste that we will see later are exactly the same when it's bio-based or when it's fossil fuel-based. And you also have biodegradable plastics that are plastics that are supposed to be biodegradable. But for most of them, they are biodegradable in very specific environments. At high temperature, at quite sometimes high pressure too. And the colleagues in the Great Britain put biodegradable plastic bags in the sea, in the nearby an harbor, during I think 2 or 3 years. And 2 or 3 years later, they took back the plastic bags that they put in the water, and they were absolutely not biodegradable, and their mechanical properties remained despite the fact that they were supposed to be biodegradable, and that they stay 3 years in ocean water. So biodegradable in very specific conditions, and bio-based that are based on the agricultural products but are still not biodegradable. And the total of both bio-based and biodegradable plastics is just 2 million tons. to be compared to the 500 million tons that is the global plastic production. So it's absolutely nothing. It's less than 1%. But well, it's quite important to know that. Why are plastics very important? And one question that you would like to raise is, what could be the future of big companies like Danone or Nestlé or PepsiCo or Coca-Cola, so food industries without plastics? 39% of the plastic production is used for packaging. And of course, a big quantity of food now is using packaging in supermarket, for instance, or if you eat, I don't know, yogurt or this kind of things, they are all with plastic packaging. It's very light, it's very easy to move, to use. So it's global production. 39% of the world production is used for packaging. And you have also other used. It's quite surprising, but 23% is used in construction and building. 8% in, I will say, transport industry. 4% in agriculture. And you also have a lot in electrical and electronics, and also other items. And if I try to put that plastics in two categories, I will say that we have the short life cycle products, so the life expectancy of these products is less than 1 year, typically. And you have the long life cycle products. Sorry, I copied the sentence, and I didn't modify it. So long life cycle products, and for instance, when you put plastics in a building, it is in the building for the duration, for the life of the building. So typically 50 years. And this is a major issue, because this means that every year 40% of the global plastic production will become waste. So if we have 500 million tons production, this means that we have 200 million tons plastic waste per year. And the question is, what are we doing with this plastic waste? So plastics is also a question of waste. So if we consider the plastic waste in Europe, we have about 30 million tons, and it's half collected in a separate way and half connected in a mixed way. And what are these wastes becoming? So when it's mixed, it's quite impossible to separate plastics from other stuff. And so most of the plastic is burnt. So what is said, energy recovery. And about 40% is landfilled, so stored inside of the soil. When it's collected separately, then it's much more easy to recycle. So 65% of this plastic is recycled, but we will see later that recycled is a very vague word, and there are many recycling are possible behind that. 27% are used in energy recovery, and despite the fact that it's collected separately, a little bit less than 10% are landfilled. And at the global scale, So it's much more than the 200 million tons that I mentioned previously. So 55% are landfilled. 75% are burnt for energy production. 8% only are recycled, and 20% are mismanaged. Mismanaged means that they are outside of a way to have a good collect and storage, and that they can reach at a moment or another the environment. Of course, this value is very heterogeneous at the global scale, and there are countries where this mismanaged part is less than 1%, really less than 1%. It's the case in France, for instance. And there are countries where there are no good solid waste collection systems. And in that case, the proportion of mismanaged plastics is larger than 20%. So this is a global description of the mismanaged plastics in terms of kilograms per person, depending of the GDP per person too. And here you have many countries. So for instance, here you have all the European countries with very few mismanaged plastics and quite high GDP per capita. And you also have, on the other side, quite poor countries with a much higher rate of mismanaged plastic waste. So I think it's quite interesting to see that despite the fact that very rich countries sometimes have very low mismanaged plastics, there are countries with quite high GDP, but also quite high mismanaged plastic rates. Where are the US? I think they are somewhere here. And there was a famous paper which was published in 2015. And this paper tried to assess the flux of plastic waste to the ocean. And it was estimated to 10 million tons per year at the global scale. And it was based on one measurement of mismanaged plastic in the US. And the rate in the US was estimated at that time at 2% of mismanaged plastic waste. And this is the second video that I wanted to show you. There is no. quite clear. I have to close and I go back to my presentation. So it was the consequence of a rain event in Kenya, and you can see that there are many PET plastic bottles that are transferred downstream with the rain, and it's, well, of course you don't see this kind of quantity of plastic bottles during rain events in France, for instance, because there are very different ways of collecting solid waste. This is quite interesting. It's not in the. This is not coming from the from France. It's coming. It's a picture. It's a photo from the US, and it's a symmetry of wind turbine blades. You know that wind turbines are widely used now, but they have a quite short life cycle because their life duration is about 20 years. And these plastics are not recyclable. And what is often done is to put them into the soil, like in a cemetery. I think it's quite impressive to see that. And so that was what I wanted to. That is, I spoke about this paper a few minutes ago, and the idea when this paper was published in 2015, and at that time they consider that the quantity of plastic transferred to the ocean was about 10 million tons, and they consider that it could reach 100 million tons in 2021, but hopefully it was not the case. It was a very pessimistic calculation at that time. But, well, it's an order of magnitude, and very often now you heard that word, that values that 10 million tons of plastics are transferred to the ocean every year. Another on the same aspect, so another paper tried to give a more precise picture of the transfer to the river, and they obtained less important values between 1 and 3 million tons of plastics per year, and they consider that 1,500 rivers contributes to 80% of the global fluxes at the world scale. And what is quite easy, so you have the map of the world, and the more red and the more big the dot is, the more plastic is transferred to the ocean. And you can see that most of the plastic transfer occurs in Asia, and it's not so surprising because the most dense population area occur in that part of the world. And so there are very big spots of plastic transfer to the ocean. For instance, in India, here in China, here in, I think it's in Philippines, for instance. But, well, in France, we consider that only 0.02% of the per capita consumption is transferred to the ocean. And this makes the situation very complicated for a country like France. It's very small value, but if you walk along a river, you will see plastic items flowing on the river. But as the value is very small, it's very complicated to try to catch all these items. It's a very small leak that occurs, and it's very difficult to control this kind of leak. For big transfer, like for instance, like the previous movie in Kenya, but there are also very fantastic movies in South America. There is an NGO which is based in the Netherlands called Ocean Cleanup that built technical boats that aim at catching the plastics that are flowing in estuaries in order to stop the transfer of plastic items to the ocean. And there are 4 big boats that are here to collect this kind of plastics in estuaries. Well, this is sorry, it's in French. I didn't check that. It's not only French. So this is the result of an assessment of plastic debris in one place in France, and so this is the percentage of the various kind of plastics that are observed in the environment. So there are plastic pieces that are impossible to recognize, but after that you find plastic bottles are quite frequent, other type of packaging, bags, polystyrene pieces, because polystyrene is often expanded polystyrene, and that makes these small plastic bullets, and they are very easily transported by wind, for instance. And you have other kind of garbage, like this also contains plastic paper items, but the most frequent are plastic items. And you know that, for instance, in France, it's forbidden to have plastic cups now. Since 2020, it's forbidden. But for most of these plastic cup, and now you have a paper cup like this one, and often you have a small turtle. Yes, and this means that there is a coating, a plastic coating inside of the cup. And for instance, if you look at what is going inside of a wastewater treatment plant, you find this kind of items. But the paper was destroyed by the friction and so on, and you just find the plastic coating at the entrance of wastewater treatment plants, for instance. So we have 2 big issues after this first part of my presentation. We have very high production, and we produce huge quantities of waste. And a part of this waste is transferred to the environment. And we will now have a look at the consequences on the environment of this plastic that are transferred there. So, a few words first to what is plastic. Plastic is like concrete. If you take concrete, in concrete you have cement, you have also big gravels, and you also have additives that are used to give to the concrete very specific properties. It's exactly the same for plastics. You have the equivalent of the cement, which is a polymer. It's a glue, some kind of glue. You also have a filler. I will describe what it is, but it's the equivalent of the gravels that are used in the concrete. And you also have additives. And one of the major issue connected to plastics is the presence of additives. So, a plastic object is a very complicated mixture. And this is a very important point to keep in mind. So, what is a polymer? A polymer is a very long molecule which is made of subunits that are repeated a great number of times. For instance, this is the basic unit of the polyethylene, and it is repeated maybe 1,000 or 10,000 times. And this makes the polymer. So you can imagine some kind of spaghetti plate that describe these polymers. And so there are two main categories. What are the ones that are called thermoplastic polymers and that are called thermosets polymer. These ones are moldable at a certain temperature, and those ones are irreversibly hard when they are prepared. So the filler. The filler, it's a product that is added to the plastics in order to reduce the cost. The idea is to mix the polymer, which is quite expensive, with something which is not expensive, but which contributes for a great percentage to the final product. So the percentage of filler can be up to 70%. So here are some average values. And for instance, if you consider a plastic chair that you can use outside in summer, for instance, the weight, the part of polymer is approximately 50%, and the other 50% is made of mineral products, for instance, calcium carbonate. So this is a very simple calculation that to show that if you consider the difference in price of the calcium carbonate and of the polymer, then if you put 50% of calcium carbonate, which is a quantity that don't modify the mechanical properties of the plastics, then the final price of 1 ton is no more 1,000 euros, but 650 euros. So it's much more interesting from an economic point of view. So these are the most popular fillers, but well, I don't want to go inside of that. So the most frequent are calcite and talc, that are mineral products. And let's move to the additives. The additives are particles, miscellaneous particles that are inside of the plastics and that give to the plastic products its interesting properties. The mechanical properties and especially its flexibility. You have a lot of plastifiers that are used in plastic items, and these plastifiers are additives. The thermal properties, the anti-shrink, so that that with time the plastic keeps its initial shape. What is quite important is the protection against the ultraviolet radiations, because ultraviolet radiations have the capacity to destroy the connections inside of the polymer. So to cut these very long molecules, and of course if you cut the molecules, then the properties is no more present. And I will go later on the questions of microplastic production, and the ultraviolet radiation is one of the most important cause of microplastic production. Many plastics includes also flame retardant. For instance, all the plastics that are used in computers contains a lot of plastic retardants. You also have dyes that give the color of the plastics, and also lubricants. Lubricants that are useful also in the plastic production, in order to produce the products themselves. These additives are very expensive. They have numerous health issues. For instance, plasticizers are endocrine disruptors, and flame retardants, for instance, include polybromodiphenyl ethers that are also endocrine disruptors. And the quantity, so we will see later that at the moment we consider that there are more than 16,000 additives that are present in plastics. And 25% of these substances are of potential concern for health issues. So it's a lot. And the proportion of additives in the plastic may reach 20 or 25% also. I think I have that later. So on average, 7%, but can be as high as 20%. So the values that I told previously, this figure is it's quite well. It was this paper was published last year, and at that time they considered that there were 13,000 additives present in plastic industry. There is another paper that was published this year, and they consider that there are 16,000 additives, so it's an always increasing number. And they are used for various effects. And what is really important is that every year, 20,000 tons of these additives are turning into waste. So it's also a very, very big quantity. And part of them are leaking to the ocean. So in 2021, 10,000 substances. In 2024, 16,000 substances. A few of the, more than 4,000 are produced at a rate larger than 100 years per year. And many of them show toxicity. And what is very important is the lack of transparency related to these additives. And this is a very, I will go back to that concerning the plastic treaty. There is a similarity between this plastic discussion, the discussions about the plastic treaty, and the climate change discussions. But if you consider the climate change, all the science is produced by the academics. So it's open science, it's really transparent, it's available to everybody. The science connected to plastic is produced by the industry mostly. The academic production, the academic science production is very small compared to the industry knowledge of plastics. And this has a very important consequence, that there is a discrepancy between the knowledge that is globally available and the knowledge that is only available by the industry. And it's very difficult to fill the gap and to have a very equilibrated discussion between the industry and, I will say, the society that will try to minimize the impact of plastics on the environment and on the health. So this is a figure of the most frequent additives. So this is from this very last paper that was produced this year. And so more than 1,500. You can find the colorants, lubricants, fillers in this figure are also included as additives. I tried previously to consider them as a separate part of the plastic production, but they consider them as part of additives. We can discuss that. You also have the plasticizers, the light stabilizers that are also the anti-UV products that also are antioxidants in order to control the effect of the oxygen on the behavior of plastics. And so you have flame retardants. And so you have many products. And you have also something very interesting that are called the NIAS, the non-intentionally added substances. That are substances that are present in the product, but that were not voluntarily added to the product. That you have side products that are formed during the production of the starting substances and that are still present in all the product. You also have breakdown products that are degradation products produced during the manufacture and the use of the constituents and additives. And you also have contaminants that are impurities that are present because the production system is not completely is not perfect. And I think it will. And it's a very specific produce because we can imagine that concerning the additives, the industry more or less knows what is included in the product, but nobody knows exactly what are present as NIAS in a plastic product. And if you discuss, for instance, with a specialist in food packaging, then he will or she will explain to you that these NIAS have the ability to move from the plastic packaging inside of the food that you are going to eat later. And we don't know exactly what it is. We know that it moves. It's possible also to make specific studies in order to assess the rate of and the quantities that are transferred. But in a general way, it's not known. A few more words concerning plastic fragmentation. So there are many causes of plastic fragmentation: the presence of ultraviolet radiation, the presence of mechanical stress, and mechanical stress that can occur at a very small scale, but also at a very wide scale. For instance, what I called the city wear and tear, because for instance, when you walk on the pavement, there are particles of your shoes that are also transferred to the environment, and this is always the case. For instance, at home, when you work on your on the soil, you also produce plastic particles if the soil is made of plastics and so on. So it's a very general. There are very general causes, and so I explained that. One major plastic particle production is also the washing machines. So when you wash your clothes that are made of plastics, you produce a lot of plastic particles, approximately 10 milligrams of plastic particles per kilogram of clothes that are washed. And this is transferred directly to the sewer system and to the wastewater treatment plant. And it was decided in 2020 to put plastic filters on washing machines, and this is supposed to be operational next January. So 2 examples of mechanical stress. So This is a conveyor belt in the canteen where I'm eating every day. And you can see all the very small plastic particles that are produced because the belt is, there is a friction that produce the plastic particles. And this is, here you can see big polystyrene blocks. And when you work with these blocks, you produce these very small plastic particles that are then transferred to the environment. The effect of radiation, so there are plastic bags that were nearby a window in my lab. And 1 year after exposure, the plastic bags is completely destroyed. And you can see that very small plastic particles are produced because of this fragmentation. So we have two categories of plastics. The big plasticals, and the idea is to weight these plastic particles in order to know how many plasticals is transferred to the environment. And you also have very small plastic particles. And then the idea is to count the number of plastic particles. The danger is much more linked to the number than to the mass. And it was decided a few years ago to consider that the limit between macroplastics and microplastics was 5 millimeters. And now we are also moving to nanoplastics, and we consider that nanoplastics are plastics that are less than 1 micrometer large. And the more the size is small, the more the risk is important for organism. So in the environment, plastic is everywhere. Here are pictures of, it's a figure of plastic concentrations that were plastic deposits in atmospheric fallout that was observed in various parts in the world. And so you can assess that the plastic deposit was varying between 100 and 1,000 microplastics per square meter and per day. So it's quite a lot. I think I have to go a little bit faster. So we observe also that the way of life had a direct consequence on the plastic deposits. So we made experiments during the COVID lockdown in 2020, and we compared that values with values 1 year later, and we observed that the deposit rate during the lockdown was much smaller than during the year 2021. So there is a link between the activity and the plastic, microplastic deposit. But what is interesting is that the concentration of plastics in indoor air is approximately 10 times larger than in outdoor air. And that, for instance, when you eat, there are plastic particles that are falling in your plate, and that you eat plastic particles during your meal. And we can imagine that, we can assess that between 6 and 60 plastic fibers are eaten during each meal. 60 fibers are eaten during each meal, and 30% of these fibers are plastic fibers. So we eat every day plastic fibers. And these plastic fibers were also observed all over the world, including the Himalaya and the Antarctica. If I move now to the soil compartment, so you have also accumulation zone of big plastics particles. This is in the Seine estuary, so 200 kilometers away from Paris. This is a figure from an island in Norway, and you can see some kind of mix of soil and plastic items. And the plastics were coming from the sea, transported during the storm events on the soil. And this is something quite different. This is, you can see, geotextile that was put inside of the soil to reinforce the soil on a hiking trail. And because of the presence of the people, the geotextile was transferred to the surface and was also destroyed, producing, because of that, many, many very small plastic particles. And you also have plastic in agricultural soil. So this is a picture in France when you have plastic mulching that is widely used in agriculture. And this is in China. And you can see that in China, the soil in many places is a mix of soil and plastics, because plastic was widely used also for plastic mulching, especially for cotton production, in order to have cotton production even in places where the water is really rare. And they developed specific tools in order to remove the plastics that was included in the soil. So it's a very, very big issue in that country. And in freshwater, so this is a plastic boom not far from here, and on the Seine River, and you can see that many plastic items are present, were stopped by this floating boom. This was also in the Seine estuary, transferred by the river on the river banks. You can find a lot of daily life items. And I saw you the small video on the plastics in Kenya during a rain event, and this is a picture from the TV during the last big flood event in 2018, January 2018, downstream Paris, and you can see that there are also a lot of big plastic items there. But you can also find microplastics, and we did an experiment a few years ago, sampling every month water at 5 points from upstream Paris to downstream Paris, and during 20 months, 19 months. And we observed that during, so you have the results on the from upstream to downstream, and we can see that there are also a lot of microplastics in the Seine River. We observe huge quantities in the Marne River, which is an affluent of the Seine River, with a confluent a few kilometers upstream from here. And what is quite interesting is to see that there is no increase in the plastic concentration, microplastic concentration, downstream compared to upstream. And it's completely, it was completely strange for us, because we have the idea that the city of Paris is a major source of pollution, and that the pollution downstream should be larger than upstream. And what we observe here is that the pollution downstream is more or less similar to the pollution upstream. And this is because there are very specific physical mechanisms that occur in the river that transfer the plastic particles from the water column to the sediment at the bottom of the river. So this is a little bit too complicated to explain. And of course, we have plastics, microplastics on beaches. So these plastics were collected in the south of France on the Atlantic coast. And you also have huge quantities of plastics in the sea. So they are concentrated in these places in the center of the ocean that I mentioned previously. And so it was, I think it was in 2014, estimated for the microplastics, 4,750 billion items. So it's a quite impressive number of plastic items. But the mass is much less than the mass of macroplastics estimated in the ocean. Plastics are also present in food. They were observed in mussels, in beer, in honey, in sugar, in salt, and also in water, and especially in bottled water. So it's much better for your health to drink tap water than bottled water, if you consider plastic, for instance. And there is also a question of migration of Nayas, so I said a few words about that. So this was my meal at the hospital a few years ago on a Sunday. There was no mineral plate, it was plastic plate. And so there is a transfer of these Nayas from the plastic plate to the food. And so many of the tea bags that probably you use are made of plastics, and many Nayas, additives, plastic particles are transferred to your tea when you use this kind of tea bags to prepare your tea. So I don't want to go to that. So at the moment, microplastics have been observed almost everywhere in the human body. So you have the blood, heart, liver, lung, body fluids, so for instance blood, kidney, endometrium, feces, sputum, breast milk, testes, semen, placenta, intestine, saliva, and recently plastic particles were observed in the brain also. So they have been observed everywhere. Maybe there are uncertainties because it's quite difficult to measure, but it's present everywhere. And there are various sources of exposure, mainly the ingestion, for instance through food, the inhalation, because you breathe, and also through skin contact. And of course, the idea is that when you, for instance, when you eat plastics, that it transfers to the gut and then it's excreted. But now it is considered that very, very small plastic particles can leave the gut system and be translocated to other places in the human body. And we have at that time absolutely no real idea of the consequences of the transfer of these plastic particles to the human body. So I don't want to go into these details because it's quite complicated. It's not complicated, but it's quite long to explain. But what is quite important is that the mean daily mass intake of atmospheric microplastic is estimated to be 0.01 microgram per capita and per day for adults, and not so different for children, and so not so different for adults. And of course, it's every day, so this means that you can that you are exposed to a regular input of plastics in your body. Well, so there is a problem, and how is it possible to solve the problem? So what is often mentioned is to recycle. So if you make a very nice circle of plastics, and then there is no more leak, there is no more transfer, and the situation is better. The problem is not solved because all the questions of the microplastic production, which is linked to this wear and tear effect, so the mechanical effect, will remain. And this is still an issue. But, well, what is it's so that there are many problems in the plastic recycling, and one problem is that only two polymers can be recycled at the moment: PET and high density polyethylene. The other can't be recycled at the moment. And for your information, there are two processes to recycle plastics. The first one is called the mechanical recycling. And in this process, you first of all, you try to separate, to sort as much as well as possible the plastics in order to have one polymer especially. Then you have to wash it very well and then to grind it, to melt it, and to produce a new polymer. That's the mechanical recycling. And there is another technique that is increasing now, which is called the chemical recycling. And in this process, you transform the long polymer chain in the very small units, and you based on these units, you try to build again the polymer. And this is probably more efficient because in using this process, it's also easier to separate the additives from the polymer in order to go back to the basic molecules and to produce a new product with the same properties than the initial one. But most of this system at the moment is used to produce indirectly energy, so it's not directly burned, but it's a fuel that is produced with this system that is later used to produce energy. So at the moment, it's quite impossible to recycle plastics indefinitely because there is no good, because the product is not pure, and that at each cycle of recycling, the performance deteriorates. And so there is a need, in order to keep some level of performance, recycled product and virgin resins. And also because it's quite difficult to sort the polymer at the beginning, and this is just two photos in order to try to show the difficulty of sorting. So this is the basic material. It's just some kind of mixture of plastics, and the idea is to separate the colored plastics with the non-colored plastics, and especially the PET, which can be recycled. So you can imagine that there are very complicated machines in order to make this sorting, because it's not possible to do it by hand. It will take too much time and too many people. So there are automatic tools to do that, but you can imagine that these tools are very, very complicated. So, yes, to fry. And so I just would like to go to that point. So this is the idea of circular economy. So one more minute because it's a problem. I think that the network is in weekend now. Oh. final breakdown. C'est bon. Okay. So this is the basic idea, to have a product that follows a circular system in order to produce the product. But in the fact, the system is much more like that. This means that it's not really a cycle, but which every new use, new recycling process, the quality of the plastic decreases, and it's much more a question. It's much more a downcycling than a recycling. And this is an example of one recycled product that you can find easily. You can see that it's some kind of resin, which is not pure. It's recycled. It's made of plastic items that were grinded and melted and then reshaped. And inside of that product, you can see other plastic particles that are used in that case like fillers, especially. So it's really similar to the gravels that are used in concrete. And the mechanical quality of this product is very bad. And with time, when it's used outside, for instance, it's very widely used in urban environment, then it's a very clear source of plastics that can be easily transferred to the environment. But, well, I just would like to close on that. So the recycling, it's more or less the plastic industry's immunity idol. So you know this show on the TV show called Survivor in the US and in France is Koh-Lanta. So you have this kind of idol that is some kind of immunity idol, and so it's the case for recycling for the industry. When there is a risk of ban or a risk of public actions, then they say, well, we will improve the recycling and we'll solve the issue. It's always the same thing, and this is the same strategy since 40 to 50 years now. And what point which is quite interesting is that there is an action against ExxonMobil that was launched in September this year in California, which is based on the fact that they say that they are always promoting and doing recycling, but that at the end they don't do anything at a very interesting scale. So another problem with recycling is that it's really less expensive now to buy virgin resins than to buy recycled resin. And a consequence on that is that the two recycling plants were closed last year and this year because it was more interesting to buy new products than old ones or recycled ones. And so just one point, there are, it was decided a few years ago to develop an international legally binding instrument on plastic pollutions, including the marine environment. And there are 4 rounds of discussion occurred until now, and the 5th year will take place at the end of this month in Korea. And there are many participants, so it's a quite great event, and with delegates, including non-governmental organizations, scientists, industry, and so on. And what is quite important to know is that the situation now is really deadlocked, and that you have two positions. One position which is called the Global Coalition for Plastic Sustainability. All the fossil fuels producing countries are in this coalition. And the idea is that you have to control the solid waste in order to avoid the environmental contamination, and that you also have to improve the recycling of plastics. And there is another coalition which is called the High Ambition Coalition to end plastic pollution, and this coalition is really based on the decrease on the plastic pollution. So it's very opposite position, and probably at the end of this month, the situation will not be solved. And so the question is, what is the position of the USA at the moment? It's not clear, because they are with the business, probably with this global coalition. But, well, there is a great concern now concerning the health issue. So I don't want to go because we don't have time. So the business coalition, and so this is the point that we can discuss concerning this treaty. So the problem is that the chemistry knowledge is in the hands of the industry. This is what I explained you previously. That there is a general refusal to apply the precautionary principle. The precautionary principle is well known now, and there is a risk for the environment. There is a risk for the human beings, but we don't know precisely the level. But in case of uncertainty, the precautionary principle says that you have to minimize the risk. And this is clearly not the position which is taken at the moment. There are quite interesting ideas. So for instance, Rwanda and Peru propose to decrease, propose a 40% decrease in plastic production. And what is also very important is to have a better knowledge of the additives that are used by the industry. And well, what is the negative aspects of the discussion at the moment is that what is the objective is to have a non-binding treaty, like for the Paris Agreement in the climate discussions. And this is very important for the USA to have a non-binding instruments. And that two big countries are considered to be able to enforce the success of the discussion, that are the USA and China. And despite the fact that there is this high ambition coalition, there are several countries that have different interests. For instance, the chemical German industry is very strong, and they still want to produce a lot of plastics. And that organization at the basis of the discussion with the United Nations Environmental Programme is a very poor structure, and also very weak. And it's also very dependent on the industry, because industry gives them a lot of funding every year. So, if you have any questions, we still have 4 minutes to discuss. But maybe it's late, and just the beginning of the weekend, on the long weekend.
Yeah, they have a lot of questions. Let's see. So questions, please.
Thanks for the presentation. Could you explain why virgin plastic is so cheap? What drives the prices? Is it related to oil prices, or what's the deal there? Okay.
Hello, thank you for your presentation. I was wondering when I came to Paris that here they don't separate between paper and plastic, or at least in my house where I live. is there evidence about different ways of collecting waste in terms of what is better for recycling?
The fact that all the recyclable products are mixed together, it's quite new, and it's from the beginning of this year. Previously, the situation was very heterogeneous all over the country, and it was really a nightmare to know in which bins you have to put your paper, your plastic, not the glass is okay, but it was, and you have recyclable plastics like the PET, and you had also non-recyclable plastics like the polystyrene. So you had to put your yogurt in one bin, and your plastic bottle, your water bottle in another one. So it was really a nightmare. And it was decided to put all the recyclable products in the same bin, glass accepted. And after that, you have huge factories where all these items are sorted in different ways. And these factories are very expensive. They were financed by the local authorities. And it was very important for them also to try to find some items that can be sold in order to recover the cost of the factory. And this is the reason why they also want to sell the PET to PET recycling factories outside of these big sorting factories. And another possibility was to develop, I don't know the word in English, la consigne in French. So when when you buy a product, you also pay an additional amount that is reimbursed when you go back with the empty container, empty can, to the seller. And this is perhaps something which is quite interesting, because it's possible to develop the reusability of the cans. We still a problem of transfer of additives and the production of macroplastics and so on, but it's perhaps better than to have more and more cans that are transferred to the waste. And this was not accepted because the local authorities wanted their money back from the factory financing, with the mostly PET selling. And so if you have the opportunity to visit such a big sorting factory, do it. It's really impressive.
Do we have other questions? Okay. So it's 6:30, so it's perfect time to finish. So thank you very, very much.